So let's look at problem number 14, the homework here. We're trying to find whether this graph given to us is the derivative, and we are trying to look for the good estimation of this expression, since the only thing we talk about estimation is a linear approximation. So that's the path we're going to go through. F of x is, generally speaking, f of a plus f prime of a multiplied by x minus a. That's the structure we have. In other words, f of x minus f of a. Again, a is always a number. That's easy to plug into the function and easy to calculate. X is the one that's hard to calculate. So if you compare those two expressions, it's quite obvious a is supposed to be 5, x is supposed to be 4.93. So I have f of 4.93 minus f of 5 is f prime of 5 multiplied by 4.93 minus 5. Namely, it's f prime of 5 multiplied by negative 0.07. Well, what is f prime? Well, the graph of f prime is given. I'm looking for f prime of 5, so it's roughly speaking here. The height is negative 4, so I'm having negative 4 multiplied by negative 0.07, so it's 0.28. That's my answer of approximation of the difference of two function values. Then I try to look at my next problem, which said, given the graph of the original function, could you please tell me among those 3 points, which one has the change of the function value? Well, this is the x-axis. Whenever I'm above x-axis, the value is greater than 0. The graph is the original function. So when I'm here, my function value is greater than 0. It's below x-axis, so they were less than 0. This is exactly 0. It was above 0, so function value is positive here, negative here, so that's where my function changes the sign, so that's a. And derivative changes sign means it's my function changing from increasing to decreasing or decreasing to increasing. So that means it's supposed to be local mean or local max, or you could just observe the trend. At this point, it's decreasing, so my function is going downwards. This, I was going up before that, going up after that, so my derivative was positive and positive. It doesn't change the sign. Here, increasing, so my derivative doesn't change the sign. Here, my function was going downwards and going upwards, so my derivative changes from negative to positive. So yes, my derivative changes the sign at the point of B. G double prime talks about concavity, so I'm going to look at the concavity of the original function. This is part of a cup, so concave up, second derivative is positive. This is part of a cup, this is part of a cup, so at all A, B, C, 3 points, their second derivative is positive, versus at this point, it was part of a cap, change to part of a cup, so the second derivative is going from negative to positive, so that's where my second derivative is changing its sign.